What happens when two black holes, the most destructive objects in the universe, smash into each other? Do they explode? Do they tear space apart? Or could the collision actually create something entirely new? Today, we're diving into one of the most violent and fascinating events in the cosmos: black hole mergers. Before we dive into the cosmos, make sure you like this video, subscribe to the channel, and turn on the notification bell so you don't miss any future space content. Imagine two invisible monsters drifting through space. Each one is heavier than millions, sometimes billions of suns. They don't emit light. They don't reflect light. They swallow everything that gets too close, even time itself. These are black holes, and when two of them meet, the universe literally shakes. To understand what happens during a collision, we first need to understand what a black hole actually is. A black hole forms when a massive star collapses under its own gravity at the end of its life. The core compresses into an incredibly dense point called a singularity, a place where our known laws of physics break down. Surrounding it is the event horizon, the boundary beyond which nothing can escape. The idea that gravity could become so extreme came from the equations of Albert Einstein, who described gravity not as a force, but as the curvature of space-time itself. Black holes are where that curvature becomes almost infinitely steep. Now imagine two of these objects orbiting each other. At first, the dance is slow. They circle at enormous distances, sometimes for millions or billions of years. But gravity is constantly pulling them closer together. As they spiral inward, something incredible happens. They release energy in the form of gravitational waves. Gravitational waves are ripples in space-time, literal vibrations of the universe. For decades, scientists believed they existed but couldn't detect them. That changed in 2015. When the LIGO scientific collaboration made the first direct detection, confirming Einstein's prediction 100 years later, a second detector, the Virgo collaboration, helped verify future events. What they detected was astonishing: two black holes colliding over 1 billion light-years away. So what actually happens during the collision? Let's break it down step by step. As the black holes orbit each other, they gradually lose energy through gravitational waves. The orbit shrinks. The speed increases. Eventually, they begin moving at a significant fraction of the speed of light. At this stage, if you could somehow watch from a safe distance, you wouldn't see two spheres crashing together. Instead, you'd see space itself twisting and warping around them like liquid. Time near each black hole slows dramatically. If you were close enough, which would be fatal, seconds for you could equal years for someone far away. The closer they get, the more violent the gravitational waves become. The frequency rises, creating what scientists call a chirp, a signal that increases in pitch until the moment of merger. This chirp is exactly what detectors on Earth measure. This is the most extreme moment. The event horizons of the two black holes touch and fuse together. Contrary to popular belief, there is no explosion in the traditional sense. There's no fireball, no shock wave of matter, because black holes contain almost no matter outside their horizons. Instead, the violence occurs in space-time itself. The collision releases more energy in gravitational waves than all the stars in the observable universe combined, but only for a fraction of a second. Let that sink in. For a brief moment, the power output of the merger exceeds the luminosity of billions of galaxies. Yet from Earth, we detect only a tiny vibration smaller than a proton. After the horizons merge, the new black hole is unstable, like a bell that's been struck. It vibrates and settles into a final shape, emitting gravitational waves in a stage called the ring down. The result is a single, larger black hole. But here's something fascinating. The final mass is actually smaller than the combined masses of the original two. Where did the missing mass go? Einstein's famous equation, E equals mc, gives the answer. Mass was converted directly into energy, the gravitational waves. Some mergers convert several solar masses entirely into energy in less than a second. That's more energy than humanity will produce in trillions of years. Do black holes ever explode? No, at least not during mergers. However, if the black holes are surrounded by gas, dust, or stars, the collision can trigger enormous electromagnetic events. Matter falling into the newly formed black hole heats up and emits radiation, sometimes producing jets moving near light speed, Supermassive black holes at galaxy centers may create the brightest objects in the universe, quasars. What would it look like up close? If you could safely observe nearby, which you can't, you'd see extreme gravitational lensing. Light from stars behind the black holes would stretch into rings and arcs. The sky would appear distorted, like looking through a warped mirror. As the merger approaches, the distortion would flicker rapidly. After the collision, the newly formed black hole would appear slightly larger and calmer. Images from the Event Horizon Telescope have already shown us what the shadow of a black hole looks like, giving us a glimpse of these extreme environments. Could Earth be affected? Thankfully, no known black hole mergers near Earth pose any threat. Even if two stellar mass black holes merged within our galaxy, the gravitational waves reaching Earth would be harmless. They would stretch and compress space by tiny amounts, far too small to notice without sensitive instruments. The real danger would only occur if a black hole came very close to our solar system, which is extremely unlikely. The most dramatic mergers involve supermassive black holes, millions or billions of times the mass of the Sun, located at the centers of galaxies. When galaxies collide, their central black holes eventually merge too. These events release unimaginable energy and can reshape entire galaxies. Scientists believe our own Milky Way will merge with the Andromeda Galaxy in about 4 to 5 billion years, and their central black holes will eventually collide. By then, Earth likely won't exist in its current form, but the cosmic event will still occur. Here's something truly wild. When two black holes merge, the gravitational waves aren't always emitted evenly in all directions. If the emission is stronger one way, the new black hole can get a kick. Some merged black holes have been predicted to shoot through space at thousands of kilometers per second, fast enough to escape their host galaxy. These are called recoiling black holes. Imagine a black hole wandering between galaxies, invisible except for the matter it devours. Do we learn physics from these collisions? Absolutely. Black hole mergers are natural laboratories for extreme physics. They test general relativity under conditions impossible to create on Earth. So far, every observation matches Einstein's predictions with incredible precision. They also help us understand the life cycles of stars, galaxy evolution, the distribution of black holes in the universe, the nature of gravity itself. Some scientists even hope mergers might reveal clues about quantum gravity, the missing link between relativity and quantum mechanics. Physicist Stephen Hawking spent decades studying black holes, proposing that they may slowly evaporate through radiation. While that effect is far too weak to matter during mergers, the combination of theories could one day unlock deeper truths about reality. Could black holes merge with neutron stars? Yes, and they do. When a black hole collides with a neutron star, the result can produce both gravitational waves and visible light. These events help scientists understand how heavy elements like gold and platinum are formed. So the jewelry you wear might exist because of cosmic collisions billions of years ago. Future discoveries, observatories run by organizations like NASA and European Space Agency are planning even more sensitive detectors, including space-based observatories that will detect gravitational waves from supermassive black hole mergers across the universe. We may soon be able to map black hole populations the way we map stars today. The ultimate question, could two black holes destroy the universe? No evidence suggests that. Even the largest mergers affect only their local region of space. The universe is far too vast to be threatened by individual events, no matter how powerful. However, studying these collisions does help us understand cosmic evolution and maybe the ultimate fate of the universe. Mind-blowing perspective, consider this right now. Somewhere in the universe, two black holes are merging. Space is rippling outward, and tiny vibrations from ancient collisions are passing through your body every second, unnoticed. You are literally being stretched and compressed by cosmic events billions of light years away. When two black holes collide, they don't explode, they transform. They convert mass into pure energy. They shake the fabric of reality. They create a larger black hole, and they reveal secrets about the universe that we could never learn otherwise. These events are among the most powerful phenomena known to science, yet they occur silently, invisibly, across the cosmos. The universe is far more dynamic, violent, and fascinating than we once imagined. If you enjoyed this video, don't forget to like, subscribe, and turn on the notification bell for more amazing space content. Thanks for watching, and I'll see you in the next video.